This video is going to be on section 1.6 notes, which is titled Miscellaneous Equations, which isn't very descriptive. But it starts off giving you some other ways to factor to solve equations. So the first method they really go through is the greatest common factor, which means that if we look here, we can see it's a trinomial. It's got three terms. And we talked in the section 1.5 notes about taking out a number if there was a number in front, but here you actually have a variable that's in common as well. So between 30 and 16 and 24, between 16 and 24, you have an 8 that's in common, but not with the 30. Between the 30 and the 24, you have a 6 in common, but not with the 16. So it looks like 2 might be the only number that's in common. So I'm going to take out a GCF of 2 and then also a GCF of the x. So 30 divided by 2 is 15x squared, because I'm taking out one of the x's as well. 16 divided by 2 is 8. Take out one of the x's. 24 divided by 2 is 12, and then take out the x. And like we did with the factoring notes before, since you're solving, if you wanted to divide the whole thing by 2 and just not even write this 2, that would be fine, and you could just put the GCF of x in the front. You cannot just divide out an x and let it disappear, because it's actually going to be a solution, which we'll see in a little bit. Okay, so this is a slide divide factoring problem because there's a number in front of the x squared. So 15 is going to slide over to the negative 12, and they're going to multiply together. 15 times negative 12, negative 180. So we're looking for two numbers that multiply to negative 180 that add to 8. So negative 180 divided by x. And we want numbers that add to 8. These numbers are adding to negative values, so I'm going to go the other direction. There we go. Negative 10 and 18 adds to 8. So GCF of 2x in front, x minus 10, x plus 18. All right, so the 15 was the number that slid over. That means we're going to divide by 15. And our next step is to simplify those fractions if we can. So 10 over 15, both of those numbers are divisible by 5. We get 2 over 3. 18 over 15, both of those numbers are divisible by 3. So it'd be 6 over 5. Okay, and then we're going to do bottoms up. So 2x, 3x minus 2, 5x plus 6. Okay, so we have three solutions. The number in the front, and then these two factors here. So this x would be 0, positive 2/3, and negative 6/5. All right, if we do the next one, looking at 42 and 36, what number do they have in common? 42 is 6 times 7. 36 is 6 times 6, so they both have a 6 in common, and then they have an x squared you can take out. So 42 divided by 6 is 7. We took out 2 of the x's, so there's 1 left over. 36 divided by 6 is 6, and we took out both of the x's. So this x equals 0. Well, x and x, there's two solutions here that both equal 0. And then that solution is positive 6 over 7. Okay. The next type of factoring is by grouping, and you'll recognize this because instead of having 3 terms and being a trinomial, it's going to have 4 terms. And then the other thing you'll notice, because not all polynomials that have 4 terms can be factored by grouping, but what you'll notice when you factor them is that if you split it in half and take out the GCF between the first 2 pieces and take out the GCF between the second 2 pieces, is the leftovers, the thing that you write in the parentheses, they'll actually be the same. So between x to the third and x squared, we have an x squared in common. And when we write the leftovers, x to the third, take out x squared, you get x. 3x squared, take out the x squared, you get 3. Over here, x plus 3, that would be considered prime. There is nothing, no GCF to take out, so I'm just going to put a positive 1 out there because there's nothing else. I'll use the 1 as kind of like a placeholder to say normally we would have put the GCF there. And then x plus 3, I'm just going to write the whole thing. So here we have 2 sets of parentheses that are identical, and in any factor by grouping problem, that's what's going to happen every single time. So now, instead of thinking of this problem as 4 terms, 1, 2, 3, 4, I'm going to think of this as 2 terms. Here's the first term, and here's the second term. And I'm going to do factoring with the GCF again. And I'm going to say that the common factor between the first term and the second term is the set of parentheses. They both have that. So I'll take out the GCF of the set of parentheses, and then I'll write the leftovers. X squared, positive 1. Okay, so this factor is negative 3. That's what that factor gives us for a solution. For this one, I'm going to say that x squared is negative 1, and then I'm going to square root both sides. So I always get a plus minus when I square root. I get 2 answers. This negative means that I'm just going to have an I with my answer. It's going to be an imaginary answer. And the square root of 1 is just 1. So this is plus or minus 1i, or you could just say plus or minus I. So 1 real answer and then 2 imaginary answers, or you could say 2 complex answers. All right. Factor by grouping again. So I'm going to split this in half. First 2. There's a GCF of x squared. X to the third, take out an x squared, you get x. 2x squared, take out an x squared, you get 2. Between the second set of 2 terms, the GCF is 5. So I'm going to take out a positive 5. 5x divided by 5 is x. 10 divided by 5 is 2. So again, here's our first term, here's our second term. The terms have the parentheses in common. So I'm going to take out the x minus 2. That's what they have in common. Then I'm going to write the leftovers. The leftovers are x squared and positive 5. So x minus 2 gives a solution of just 2. X squared plus 5, we can say that x squared is going to equal negative 5. And then I'll square root both sides. X is plus or minus. The negative means that my answer is imaginary. Square root of 5, that's not a perfect square, so I can't actually square root 5, and so that's just my answer. So plus or minus I square root 5. All right. Next is factoring using the sum or difference of cubes. The sum of cubes, the difference of cubes, and I've written the formulas for you. You'll notice the formulas are the same, but the signs are a little different. And the way that I've always remembered how to do the signs is to remember the acronym SOAP. SOAP. So keep the same sign as the problem. This is a plus, that's a plus. Opposite sign from the problem, and then always positive. So negative, same sign, opposite sign, always positive. SOAP. So that helps me to remember it. Yeah, let's go ahead and just get into this one. So I'm going to make it equal 0 to start with. So 2x to the 5th minus 16x squared And I can see that the problem already has a GCF, so I'm just going to take that GCF out. So 2 can come out of both of those, and then x squared can come out of both of those. So when you have a GCF that's a variable, it's always the smaller exponent of the two of them, or of the three of them, or whatever. So we took out the 2, x to the 5th, we took out 2 of those, so this is going to be x to the 3rd. 16 divided by 2 is 8. And then the x squared we had already taken out. So we have x to the 3rd minus 8. All right, so 2x squared. 8 is a perfect cube. It is 2 to the 3rd power. So we have x to the 3rd minus 2 to the 3rd. Okay, so we've got 2x squared, and then I'm going to write my signs. So same sign, opposite sign, always positive. Okay, so I do x minus 2, and then x times x is x squared. X times 2 is 2x. 2 times 2 is 4. Okay, so that's just me using the formula. X minus 2, x squared, x times 2, 2 squared. Okay, so I've got this. I know I've got real solutions of 0 and positive 2. And then whenever you're solving sum or difference of cubes, you're always going to end up with this quadratic here. It's part of the formula. And this quadratic is always going to give you imaginary complex roots. Always. So this one, we don't have space. And you've probably seen enough of these examples by now. But you're going to use the quadratic formula to get the other two answers for that example. And if you wanted to take the time to do the quadratic formula for those, you would end up getting -1 plus or minus I root 3. Those are the other two answers. They come from the quadratic formula. Okay, let's try the next example. Again, we're going to make it equal 0. So 3x to the 4th plus 81x equals 0. I'm going to factor out a GCF of 3 and a GCF of x. So that leaves me with x to the 3rd. 81 divided by 3 is 27. (27) is 3 to the 3rd. So for my factors, I'm going to have same sign, opposite sign, always positive. And the pattern here is to do the a value and the b value. So x and 3. A times itself, so x times itself. A times b, x times 3. And then b times itself. 3 times 3 is 9. So the first two solutions are 0 and -3. For the last solution, you would need to use the quadratic, that's going to be an F, formula. So the two answers from the quadratic formula are 3 plus 3i root 3 over 2 and 3 minus 3i root 3 over 2. And again, from the quadratic formula. All right, difference of squares. It's going to be a little bit more comfortable. We learned how to solve a problem like this by taking square roots, but you can also factor it using difference of squares. So if we have x to the 4th equals 49, we're going to make it equal 0. X to the 4th minus 49 equals 0. And I'm going to rewrite this as something squared minus something squared. So this is x squared squared minus 7 squared. And then the way that we factor this is we have two sets of parentheses, one with a plus, one with a minus. So we have x squared plus 7, x squared minus 7. Okay, for the x squared minus 7, this is the difference of squares again. So I'm going to keep this. So something squared, if we were to write 7 as something squared, it would be the square root of 7 squared. So I'm going to say this is x plus the square root of 7, x minus the square root of 7. So this is that factored form, completely factored. And for my solutions, I'm going to say negative square root 7 and positive square root 7. And then over here, these are going to give me my imaginary solutions. I'm going to say x squared equals negative 7. And I'll square root to solve. Plus or minus. The square root of a negative gives me an I. And 7 is not a perfect square, so I'm still going to have a root in the answer. So for our real solutions, we have negative root 7, positive root 7. And then we've got plus or minus I root 7 as well, imaginary solutions. Okay, for this one, we have a GCF of just x. That leaves us with x squared minus 10. And this is the difference of squares. Normally I prefer if this is a perfect square right here, but it's not, so it's just going to look like this when I rewrite it. So x, and then I'm going to have x plus square root of 10, x minus the square root of 10. X equals 0, x equals negative root 10, x equals positive root 10. All right, we have a few more factoring problems. These they call quadratic type, where they look kind of similar to the quadratics that we've factored before, but the exponents are wrong. So I'm going to think of this as x squared minus 14x plus 45, because I know how to factor that. This is like what we would have done before. So I would have said what multiplies to 45 and adds to negative 14. And that would be negative 9 and negative 5. And so in my parentheses, I'd get x minus 9, x minus 5. But that's not the problem we were doing. The problem we were doing was x to the fourth minus 14x squared. So the x's that we had in the problem are actually just squared. It's the square version of the normal problem. So it's x to the fourth, x squared squared is x to the fourth, and then x squared instead of x. So what I'm going to do is I'm just going to take my solutions and I'm going to do exactly what I would have done to this to make it that equation. I'm just going to square those x's. And now I can finish it. So x squared minus 9, that's difference of squares. So that's going to be x, and then 9 is a perfect square, so x plus 3, x minus 3. And then 5, again, we have difference of squares, but 5 is not a perfect square, so I'm going to say x plus root 5, x minus root 5. So I have 4 solutions, all of them are real. Negative 3, positive 3, negative root 5, positive root 5. Okay, let's try it again on the next problem. So x to the fourth plus 14x squared, I'm going to make the problem equal 0. This looks really similar to x squared plus 14x minus 32. And if that is the problem that I was doing, I would be looking for two numbers that multiply to negative 32 and add to 14. So two numbers that multiply to negative 32 and add to 14 would be 16 and negative 2. So x plus 16, x minus 2. Okay, but these are not the same equation. This was squared and this was squared, which means what I'm going to do is go into my factors and make the x's squared there as well. So now this is the sum of squares, which is not something I can factor, so I'm going to solve that in a minute. But here I can do x plus root 2, x minus root 2. Okay, so my real answers are negative root 2 and positive root 2. And then over here, I'm going to need to solve that and get my imaginary answers. So x squared equals negative 16, and then I can square root each side. Plus or minus. There's a negative underneath the square root, so that's going to be an I. And then the square root of 16 is 4. I'm not going to write I of 4, that's going to look weird. So 4i. Okay, next we're going to look at how to solve radical equations. And when you solve radical equations, you have to beware of something called extraneous solutions. And extraneous solutions are solutions you can find when you're going through and doing the problem. You've done the problem correctly, you get an answer for x, but if you take that x value and plug it back into the equation, it just doesn't work. And you'll notice these in things like square root problems, in logarithmic problems, in absolute value problems. There are things where like you can't square root a negative. Absolute values only output positive answers. You can't take the log of a negative number. You can't take the log of 0. So anything that has like a special rule like that is going to potentially have an extraneous solution when you're looking at an equation. Okay, so the first problem, anytime you have an equation that's written like this, where you have one radical in the problem and it's all by itself, you can just go ahead and square both sides to get rid of that radical, so that square root sign. So square the left side, square the right side. I'm just going to write the left side again. Okay, the right side is x minus 2. I'm going to write it out twice. So the square root of x squared, the square root and the square root, they cancel each other out, and I just get x. And then over here, we have to multiply out these parentheses. You might think of it as foiling. So x times x squared, x times negative 2, negative 2 times x, negative 2 times negative 2. And I'll go ahead and I'm combining like terms on the right side. And so what I have now is I have a quadratic. If I covered this up, it would look, just like a quadratic. It just happens to have an x on the left side. So I'm going to subtract the x over to make this equal 0. And then with quadratics, I usually try to factor them first because that's the easiest method, in my opinion, for solving. So I'm looking for two numbers that multiply to positive 4 but add to negative 5. And those two numbers would be negative 4 and negative 1. So the factors are x minus 4, x minus 1. That means that the potential solutions are positive 4 and positive 1. And they're potential solutions because I don't know if either one of them is extraneous. So what I'm going to do is I'm going to grab my calculator. I'm going to take 4, hit the store button, STO, store this for X. And then I'm going to make sure that if I plug in the left side of the equation, square root X, and plug in the right side of the equation, X minus 2, it gives me the same answer, and it does. They're both 2. So 4 is a good answer. Then I'm going to take 1 and store it for X. I'm going to do the same thing. I'm going to square root X, that's the left side of the equation. For the right side of the equation, I have X minus 2. I do not have the same answer. I have 2 different answers, 1 and negative 1. That means that 1 is an extraneous solution. I solved for it, I did all my math correctly, but it doesn't work as a final answer. Okay, let's try the next problem. So if you have a problem that has radicals, more than one radical, you can only have one radical on each side. So I'm going to take the square root X, I'm just going to move it to the right side. So we're going to have square root of 2x plus 1 and square root x plus 1. It's a plus 1 because that 1 is positive. And now I can go through and I can square both sides. And the bummer about the right side is that it's got 2 terms to square, which means we have to write out those parentheses so that we can multiply and distribute everything correctly. This is a foiling problem over here. So I've got root x times root x squared, which is just x. Then I have root x times 1, which is root x. Then I have 1 times root x, which is just root x. And then I have 1 times 1. So on the right side, I have x plus 1, and then I have 1 root x and another root x, and that gives me 2 of them. Okay. On the left side, the square root and the squared canceled out. I have 2x plus 1. Okay. So if you're doing a problem and this happens, and this is going to be the case probably with all the problems that have 2 square roots, you still have a square root in the problem. And so now we kind of resort back to what we did on the first example, which is we say if the square root is all by itself on that side, then we can go ahead and square both sides. Well, for this equation, the square root is not the only term that's on the right side. So I'm going to subtract the x over to the other side and subtract the 1 over to the other side so that this root x, that term, is the only thing left. So 2 root x, the 2 in the front is okay, we can handle that. But the root x is the only thing on the right side now. And then on the left side, the 1's cancel. 2x minus 1x is just x. So I'm going to have to square again. I got to get rid of that radical. So x squared is just x squared. 2 root x. Now you can do this the way it's written if you want, or if it's hard for you to imagine how to square that when it's got a coefficient in the front, you could just write it out. 2 root x times 2 root x. Well, 2 times 2 is 4. And then root x times root x is just x. Or you could say it's the square root of x squared, which is just x. Okay, so we have a quadratic now because we have an x squared, and then there's also an x term. So this is something I can factor. I just have to make it equal 0 first. So I'm going to take this positive 4x, I'm going to subtract it over to the left side. And now the right side is 0. And this is a GCF factoring problem. There's an x in common. X squared, take out an x, you've got an x left over. 4x, take out an x, you just have the 4. And so there are two solutions, x equals 0 and x equals 4, but wait, we don't know if both of those solutions are good solutions or if one of them could be extraneous. So I'm going to go through and I'm going to do 0 stored as x. I'm going to type this problem. Square root 2x plus 1 minus square root x, and I want to make sure it equals 1, and it does. Okay, now I'm going to do 4 stored as x, and I don't feel like typing this again, so I'm going to go up here. I'm going to copy paste, and it's going to plug in that new x value. I still get 1. Okay, so both of those answers are good. We have two solutions for this problem. Okay. Next, we're going to be looking at equations with rational exponents. Rational exponents just represent square roots, cube roots, fourth roots, but then also things that have been raised to a power. So it's been raised to a power, but also it has a root. And that's what a rational exponent does. So if we have, I'm just going to jog your memory here. If we have x to the m, let's see, over here, m over n is how they write it. X to the m over n is the nth root of x, all raised to the m power. That's one way to think of it. Or you can also think of it as x raised to the mth power, and then you take the nth root of it. Two different ways of thinking about it. I tend to go back and forth between them, depending on which way would make my life easier when I'm solving the problem. So you can do it either way. Okay, so if I have x to the 2/3 equals 4, and I want to get the x alone and get rid of the exponent, then I need to raise both sides to a new exponent to make this exponent cancel out. So I'm going to raise both sides to an exponent of 3/2. And the reason I'm going to use 3/2 is because 2/3 times 3/2 is 6/6. And 6/6 is 1. X to the 1 is just x. And so that's me getting my x alone. So I have x is 4 to the 3/2. So I can think of this two different ways now. I can think of this as the square root, the 2, that's an nth root, the square root of 4. And be careful, that's plus or minus because it's a square root. The square root of 4 to the 3rd. That's one way. Or I can think of this as 4 to the 3rd, and then I take the square root of it. So in this situation, I prefer the first one because I like to make the number smaller first, do the square root, and then make it bigger by raising it to an exponent. So I've got positive 2 raised to the 3rd power. 2 raised to the 3rd is 8. I've got negative 2 raised to the 3rd power, which is negative 8. So this is plus or minus 8. 4 to the 3rd is 64. And then the square root of 64 is plus or minus 8. So you're going to get the same answer either way. It just kind of depends on how your brain likes to think about the problem. Okay, for the next one, we're going to get rid of the exponent by raising this to the negative 2/5. We got to get rid of the negative, but also get rid of the 5/2. So I'm going to raise this to the negative 2/5. So I have x minus 2 equals 32 to the negative 2/5, which means I have two different ways I can do this. I can do the 5th root of 32, and I don't have to do a plus or minus because this is an odd root. I only have to do plus or minus if I have an even root, square root, 4th root, 6th root. So I have the 5th root of 32, and then I can raise it to the negative 2nd power. Or I could do 32 raised to the negative 2nd power, and then take the 5th root of all of that. So again, this is going to be easier for my brain. So the 5th root of 32 is just 2. I'll prove it to you. So I'm going to type in a 5. I'm going to hit the math button. I'm going to tell my calculator to do that type of root, the nth root. So fifth root of 32 is 2. Okay, so fifth root of 32 is 2, so this is 2 to the negative second power. Negative exponents just mean that if we write a fraction, they're on the bottom of the fraction. So this whole thing would be moved to the bottom. So I've got 1 over 2 to the positive second. And so this is 1/4. The danger of just taking these problems and typing them in is that if you take 4 and raise it to the 3/2, you're only going to get one answer 8, even though 2 answers will work for those. So if and actually I need to check, you should always check for extraneous solutions. We'll go back and check for that. And then over here, these, you would be able to find them every time. However, it's better to do it by hand so that you can make sure if you should be getting 2 answers or just 1 answer. The strategy is down here to kind of help you, but I think this is a little bit confusing. So I just like to think if it's a even root, I have plus minus. If I'm not taking an even root, then I just have 1. Okay, so let's plug these answers in and just make sure that they're good. So x, I'm storing the 8 as the x, and then I've got x to the 2/3. That gives me 4. I've got negative 8 stored as x. Negative 8 to the 2/3, also 4. So both of those answers were good. For the next one, I've got, you know what, I wasn't even done with the 1/4. We have to be really careful here. I did all of this work, and it was x minus 2 was equal to this number over here. So x minus 2 equals 1/4. I'm going to add the 2 over. 1/4 plus 2. I'm going to hit the math button to turn this into a fraction. 9/4. Okay, so if I store that as x, then I can type in x minus 2 to the negative 5/2, and it gives me 32, so that's a good answer. If you were doing a problem where you only had one answer, and that answer happened to be extraneous, then you would cross out that one answer and you would say no solution. So it is possible for that to happen, even though it doesn't happen all the time. Okay, let's look at these next ones. So these are kind of similar to what we did on the previous page of notes, where we said, let's do a quadratic type of problem. You can see that they are written kind of similarly to these examples. So I'm just going to write what I know. X squared minus 9x plus 8. That is a problem I would have known how to factor. And so two numbers that multiply to 8 and add to negative 9 would be negative 8 and negative 1. So if I look at this problem, the way that they must have gone from here to here is they took this and they raised it to the 1/3 power. 2 times 1/3 is 2/3. They took this x and they raised it to the 1/3 power. That's just 1/3. So if I write my factors, x minus 8, x minus 1, then I'm just going to do the same thing. I'm just going to raise them to the 1/3. X to the 1/3 minus 8, x to the 1/3 minus 1. So to solve these, I'm just going to write that x to the 1/3 equals 8 and x to the 1/3 equals 1. And then to solve this for x, to get the 1/3 to go away, I just have to raise each side to the 3rd power. That first one's going to be a big number. So x is 8 to the 3rd 512. X equals 1 to the third, which is 1. And we can always check and make sure our answers make sense. So 512, store it as x to the 2/3 minus 9x to the 1/3 plus 8. So this is an interesting one because your calculator would be struggling here to say 0. This is your calculator trying to say 0 and having a hard time. 4e to the negative 12 is scientific notation, and it means that it had the number 4, a decimal point 4, and then if you took the decimal point, you would move it 12 places to the left and put zeros there. This is just my calculator struggling. So it really did equal 0. It's just having a hard time calculating that. And I'd be interested if you guys try this too to see what your calculator said with that. And that's only because we had such a large number that we were plugging in. Let's try the other answer was 1. This one should 0. So it equals 0 like it should. Anytime you see this on your calculator, and unfortunately your calculators do this every so often, anytime you see this here, or if you're looking for an x-intercept or a y-intercept, you'll often see these there too. It's your calculator trying and struggling to say 0. So this number, if we were to write it out, you don't have to write this on your notes. I just want you to understand what the calculator means when it says that. It's giving you the answer in scientific notation, and it's saying take 4, put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros in front of it, and then put the decimal point. This is what it's trying to tell you. It's just a limitation of technology. It's because we had a really large number plugged in. But it equals 0 is basically what we need to get out of that. Okay, the right side of the problem for our next example over here, the second example, we have a 1/4. And so I'm going to go ahead and just raise both sides of this equation to the 4th power. So on the right side, we just have x to the 4th. On the left side, the 4th and the 1/4, those cancel each other out. We're just left with what's inside here. 11x squared minus 18. And so this is another one of these quadratic types. And we want to have the x to the 4th so that it's positive. So I'm going to minus the 11x squared, add the 18. So we have x to the 4th minus 11x squared plus 18. So I'm looking for two numbers that multiply to 18 that add to negative 11, and that would be negative 9 and negative 2. So x minus 9 and x minus 2 is what we would have if this had said x squared minus 11x plus 18. But since it says x to the 4th minus 11x squared plus 18, that means that these have to be squared. So I can factor those. Those are both difference of squares. Technically the second one isn't, but we can just use radicals. So 9 is a perfect square, so we can do x plus 3, x minus 3. And then for the next one, we'll go ahead and use difference of squares. Even though 2 is not a perfect square, we'll just use root 2, x plus root 2, x minus root 2. And we have 4 solutions. Negative 3, 3, negative root 2, root 2. All right, we have one last type of equation. That is absolute value equations. So you might remember that with absolute value equations, whenever you have an absolute value sign, it always takes whatever's in front of or whatever's inside of the absolute value and it just makes it become positive. That's how absolute value signs work. So we're going to say that when you did this problem, it is possible that x squared minus 6 gave you a positive output, or it's possible that x squared minus 6 gave you a negative output and the absolute value signs just made it positive before they spit it out. Those are your two possibilities. So whenever we solve absolute value equations, we're always going to have two options, the positive and the negative. So both of these are quadratic, so I'm going to go ahead and make it equal 0 so that I can factor. So for this one, I'm looking for two numbers that multiply to negative 6 but add to negative 5. That would be negative 6 and positive 1. So the two solutions are 6 and negative 1. And we're going to check for extraneous solutions because anytime we have some limitation on the type of function they're using absolute value functions. Anytime there's some type of limitation, it could mean that some of the answers won't end up working. For this one, I'm going to add 5x over, make it equal 0. X squared plus 5x minus 6 equals 0. Looking for two numbers that multiply to negative 6 but add to positive 5. So positive 6 and negative 1. And so your solutions are negative 6 and 1. So we have quite a few answers to check here. So I'm going to do 6 for x, just going in order. So to type in an absolute value, you hit the math button. And you go over to number, and so I'm going to type in x squared minus 6. Okay, so if I plug in 6, I get 30, and then 5 times 6 is also 30. So the left side is 30, the right side is 30 if I plug in 6. Okay, so that one worked. Negative 1 stored for x. Plug it in. Okay, the left side is 5. If I plug negative 1 into the right side, I get negative 5. So negative 1 does not work. Okay, let's try negative 6. Okay, if we plug it in, we get 30. If we plug negative 6 into the right side, we get negative 30. So negative 6 does not work. Positive 1. If we plug in positive 1, we get positive 5 on the left side. If we plug in positive 1 on the right side, we get positive 5 as well. So 1 works. So your actual solutions are 6 and 1. And you can't just say the positive answers work and the negative answers don't. That was coincidental for this problem. That's not going to be the case for every single problem. So be careful of that. All right, last example of this very long video. So each side is an absolute value. The inputs of each were forced to be positive. So either they truly were equivalent or they had opposite signs and the absolute value just forced the numbers that were already the same size and just opposite signs, forced them to become positive. So we have x minus 1 could equal the positive version to x minus 3. Or x minus 1 could equal the negative version of 2x minus 3. So if I solve this one, I'll just take this x and subtract it over. And then I'll take negative 3 and add 3 to the left side. Negative 1 plus 3 is 2. So there's one solution. Over here, I'm going to go ahead and distribute the negative. I'll get my x's to one side. I'm going to add the 2x to the other side. And then I'll add the 1 over to this side. Okay, so I need to check both of these answers. So I've got 2 little stores x. Type this in, x minus 1. 2x minus 3. Okay, so if I plug in 2, both answers work. Now I'm going to try 4/3. Okay, so with the first one, okay, copy paste it into the second one. They're the same as well. So when I plug in 2, the left side and the right side give the same output. When I plug in 4/3, the left side and the right side give the same output. And so I know that both of those solutions are good solutions. They both work.